In this lesson, we will learn about Windows DNS zone implementation. We will first start with answering the question, what is Windows DNS zone? Then we will learn more about primary zones, secondary zones, stub zones. After that, we will learn about conditional forwarders, zone compatibility. Finally, we will sum up our lesson with the keynotes. So what is Windows DNS zone? A Windows DNS zone is a container that stores DNS records for a specific domain hosted by the DNS server. When created, each zone creates an entry in the DNS server registry with the name of its domain. So here is the path for the Windows registries, and here is all the zones created in this DNS server. A Windows DNS zone can be implemented as standard files stored in system root, system32 DNS folder, where each zone file has the default file name as domainname.dns, or it can be implemented as AD integrated, stored in the application partition of the Active Directory database. For example, if we create the zone for the domain itlifeskills.local as the primary zone only, so a new zone file is created in C Windows System32 DNS folder with the zone file name as itlifeskills.local.dns. However, if we create the zone for the itlifeskills.local as the primary zone with the option to store the zone in the Active Directory, then the zone will be created in the Active Directory database application partition. Let's now learn about primary zones. A primary zone of a domain is the zone that allows to create, update, and delete DNS records of the domain. It also allows to create new child domains or delegations. Primary zones can be implemented as standard files or Active Directory integrated. The next zone type is secondary zone. A secondary zone of a domain is the zone that gets the copies of all the DNS records transferred from its primary zone DNS server. No updates can be made directly to secondary zones. Therefore, secondary zones can only be implemented as standard files. As you can see in this screenshot, when we select the zone type as a secondary zone, the option to store the zone in Active Directory is grayed down, which means secondary zones can only be implemented as standard files. The next zone type that we can create is stub zone. A stub zone of a domain is the zone that only loads the records of the authoritative DNS servers of that domain from its primary zone DNS server. Stub zones can be implemented as standard files or Active Directory integrated. As you may know, delegations can be configured on a primary zone domain to have its child domains hosted by other authoritative DNS servers. Delegations inherit the zone implementation of the parent domain. So in this screenshot, we have the primary zone for the itlifeskills.local, and we configure the delegation for the child domain hq.itlifeskills.local. In this case, if itlifeskills.local zone is a standard file, then hq.itlifeskills.local is also created as a standard file. And if itlifeskills.local zone is AD integrated, then HQ is stored in Active Directory. Let's now learn about conditional forwarders. As you may know, conditional forwarders contains pointers to either authoritative DNS servers or recursive DNS servers of the domains. Conditional forwarders can be implemented as AD integrated. If not, the domain information configured in the conditional forwarders will only be stored as entries in the registries of the DNS server. So in this screenshot, we configure the domain cisco-skills.local in conditional forwarder. If we do not configure it as AD integrated, so the domain information will be stored as an entry in the registries of the DNS server GPVDC01. Now that we have a good understanding about zone types and their implementations, let's learn about zone compatibility. When a zone of a domain is configured as primary standard file on a DNS server and another primary standard file zone for the same domain is created on another DNS server. For example, we created the domain itlifeskills.com as primary standard file zone on GPVDC01 and GPVDC02. These two zones are not replicated to each other, so any DNS records of the domain must be created, updated, and deleted on both servers, and it is not recommended to do that. Let's learn about the next scenario when a zone of a domain is configured as a primary standard file on a DNS server and a primary AD integrated zone for the same domain is created on another DNS server. For example, we created the domain itlifeskills.com as primary standard file zone on GPVDC01, and we created the same itlifeskills.com as the AD integrated zone on GPVDC02. With a proper configuration option, the AD integrated zone itlifeskills.com on GPVDC02 can be replicated to other DNS servers in the same forest, but not to the one created with the primary standard zone file, which means we have to create, update, and delete DNS records for itlifeskills.com domain on GPVDC01 independently from other DNS servers, and this configuration is not recommended. When a zone of a domain is configured as primary standard file on a DNS server, here are the possible options to configure to make the domain available on other DNS servers. The first option is to configure the secondary zone. The second option is to configure the stub zone. And the last option is to configure conditional forwarders. When a zone of a domain is configured as AD integrated on a DNS server, for example, we configure the zone for itlifeskills.com domain as primary ID integrated on GPVDC01. Here are the possible configuration options. If we choose this option, the zone for activelifeskills.com domain will be replicated to GPVDC02 because it is in the same domain with GPVDC01. Now, if we choose this option, then the zone for itlifeskills.com domain on GPVDC01 will be replicated to all the DNS servers in the same forest. Please note that it is possible to use the primary ID integrated DNS server as the master for the secondary stub zones or conditional forwarders DNS servers. This is the end of this lesson. Let's read the keynotes.